Okay, so we've been talking about a simple random sample technique. That is not the only good random sampling technique. There are, of course, other good random sampling techniques. The first one that we're going to cover is called a cluster sample. To get a cluster sample, you start by classifying the population into groups of individuals, usually that are located near each other, called clusters. Then you choose a simple random sample of the clusters. All individuals in the chosen clusters are included in the sample. So we're going to break the people into groups, usually groups kind of associated by location or some kind of convenience. We're going to pick a certain number of those groups, those clusters, and we're going to survey everyone in those clusters. For example, a large school district contains 80 schools. The administration wants to survey parents to estimate the percentage of students that have internet access at home. The school randomly selects 10 of those schools, so these 80 schools would be the clusters. Then they're going to take a simple random sample of 10 of the schools and survey every parent in those schools. This is a cluster sample. Note, this technique is only effective. This isn't exactly right. Is maybe usually only effective if each cluster is representative of the entire population. The clusters are each heterogeneous representatives. Yeah, this isn't exactly right. I'm going to put a little X by this. It's kind, the thing is, for example, let's just talk about it. So we got 80 schools. We got 80 schools that we're choosing from. We're going to randomly select 10 of them. So I'm going to number them from 1 to 80, and then I'm going to take a write 1 to 80 on little slips of paper, put them into a hat, mix them up. Maybe I get the third one, maybe I get the eighth one, and I'm going to get 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then I'm going to go to those 10 schools and survey everybody. So what I was saying here is that every cluster should be kind of representative of the population. That's not necessarily true. Like, this could be like a rich school where everyone has internet access, and this could be kind of a poorer school where nobody has access or something, or a smaller percentage of people have access. That's going to be okay as long as you're selecting 10 schools out of the 80, or maybe 20 schools out of the 80. Now, if we were only selecting 2 schools, now we might have some problems, right? In an ideal situation, every school is going to kind of be representative of, kind of similar, have, wealthy people and poor people or something like that. Every school should kind of be balanced. But as long as you're getting enough clusters, it's not that big of a deal. What's the benefit of cluster sampling? The benefit is it's easier to do. If we do a simple random sample, then I'm going to have to go to every single school and survey certain kids. Here, I can just go to these 10 schools, give the survey to everybody. That's going to be a lot easier. The reason we do cluster sampling is because it is easier. Okay? Stratified sample. Stratified sample, we're going to break them into groups again, but this time we're going to classify the population into groups of similar individuals called strata. Here we want to group people together that are very alike, homogeneous groups. Then we're going to choose a simple random sample from each of the stratum and combine those into making a sample. Company wants to gauge employee satisfaction. They divide up their employees into the following groups. We've got engineers, accountants, maintenance, administration. And these are all going to be kind of similar groups, right? Like the administration, they're all, the maintenance, each group is kind of probably got its unique characteristics within the group that are different from other groups. Then they randomly select 50 employees from each group to form the 200 people. So that's a stratified. Here we got 4 groups, but instead of in cluster, we would take a random sample of 2 of the groups and survey everybody. Here we take a simple random sample of 50 from each group. All right, we're breaking them into groups of like people. I need to get representation from each of the groups to make my sample of 200. Okay, this is kind of usually what people think of whenever they think of a sensible sampling technique. What's the benefit? If the strata really are different across the responses being recorded, then this technique can yield a sample statistic that is on average closer to the true population parameter than a comparable statistic taken from a simple random sample. So this is a complex idea. We talked a little bit about it in class. I don't know. Should I talk about it here? Yeah, maybe I will. So if we were to take a simple random sample from this company, we're asking about job satisfaction or number of hours you work or something. Job satisfaction or something. I don't know. If we take a simple random sample, maybe this is the true proportion of people that think they're doing a good, that like their job, right? If I take a simple random sample, I'm going to get p-hat values that are kind of like this. They're going to be kind of, some of them are going to be close to the true value. Some of them might be a little bit further away. But not biased, just balanced kind of all around, right? And maybe we get this high proportion because we just happen to get like 60 administrators in a group and only 30 maintenance staff. Because when you just put all the names into a hat, you might just get more administrators than you do maintenance staff. And maybe this sample here happened because I got 55 maintenance people, and the maintenance people aren't happy with their job, and we only got 25 administrators. Maybe the administrators are happier with their job. So maybe we got a low p-hat here because we got a lot of maintenance people and not very many administrators, and maybe we got a really high one here because of the opposite happened, right? This happens when you take an SRS. You could get more of one group than another group because we're just putting names into a hat. Now, if we do a stratified technique, true population is the same. We are not going to get this sample nor this sample because we're going to get 50 of each. So there's still going to be variability. Of course, there's going to be variability. Maybe not all administrators like their job. Not all maintenance people hate their job, right? But the variability is going to be much less because I don't get those samples where you get a lot of one group and a small number of another group. So it kind of reduces the errors in our estimate from those samples that are like that, I guess. So the advantage of a stratified technique is if these groups really do have similar opinions within the groups and different opinions across the groups, outside of the groups, between the groups, then your p-hat estimate might be closer on average than if you take a simple random sample, okay? And that's a good thing. So that is an advantage of the stratified technique, okay? A/B testing tip, you can easily distinguish between a stratified sample and a cluster sample. Please don't focus on how the groups are formed, whether they are similar individuals or whether they are located near each other or heterogeneous groups of people. That's not what the most distinguishing factor is. In a stratified random sample, you take some people from every group. In a cluster sample, you take some of the groups and you survey everybody. So in the cluster sample, I'm going to randomly select 10 schools and then I survey all the people at those 10 schools. All. But I don't take anybody from those groups. In a stratified technique, you break them into groups, and then you take some from every single group because you want representation from every one of those homogeneous groups. So look at it as who you're taking, whether you're taking some from every group or whether you're taking everybody from a few groups, okay? A systematic sampling technique. A systematic random sample is created by first taking an ordered list of all the members of the population, randomly selecting a starting member for the sample, and then selecting every kth member from the list. For example, in AP Stat class, you want to survey 10% of the student body that come into school on a given day. You run random integer on your calculator, 1 to 10. You get a 7. So then you stand by the door and you give the survey to the 7th kid that comes in, the 17th kid, the 27th kid, the 37th kid, so on and so forth, until all the kids are at school. So you're taking roughly 10% of the population and That's how it is. That's called the systematic technique. Every 10th person. And it's still random. We're using a chance process, right? Multi-stage sampling, let's not worry too much about multi-stage sampling, but in a multi-stage sampling technique, we're going to use combinations of these different sampling techniques several times at different stages. For example, we want to take a sample of people from the United States. Oh my gosh, that's a horrible United States, but whatever. So there's 50 states. So I'm going to randomly take 5 of the states. Randomly, right? California, Florida, and Texas. Yeah, random. No, let's just say it was random. So I randomly take 5 of the states, and then I divide each state into their counties. They're already divided into counties. I'm going to look at the counties, and then I'm going to take a simple random sample of 100 people from every county in that state. So every county in all the 5 states. So this is a multi-stage technique. In stage 1, we're doing a cluster sample because we are taking 5 out of the 50 states. But if it was a true cluster sample, I would just take the clusters and I'd survey everybody. But I'm not surveying everybody in the state. Instead, on stage 2, I'm stratifying. I'm taking every single county and I'm taking an SRS from every single county. So this is stratified. So on stage 1, this would be a cluster. Stage 2 would be a stratified. Yeah, that's a multi-stage technique. So obviously these sampling techniques can get pretty complicated, but we're not going to get too complicated in this class, okay? I'm going to skip this. Senior privileges. I'm going to stop the video.